I think this is definitely a good question for a whiteboard interview, okay? And if you don't know BIT,
your interview is timed. That means you don't have all day to come up with a perfect solution. Done is better than perfect. Your first priority is to implement a working solution. You can always optimize it later if you have time.
Hey guys, welcome back. Today I have a problem from Leetcode. In this problem, in short, I will say we have to actually take the elements from the instructions array and we have to form another list which is actually a sorted array. If you see this example, finally we are getting 1, 2, 5, 6, but the given array is 1, 5, 6, 2, right? So finally we are going to get a sorted array or sorted list. So there is a cost that has to be calculated each time we insert an element. Finally we will return the total cost from this operation. So what is the cost here? Okay, let's take this example. 1562, okay, and while creating this sorted array, initially we will have a empty list, okay, and after that we take this one and we insert this element. For this operation, what is the cost? We will calculate how many numbers, how many elements are there in this particular list which is less than 1, and how many elements there are in this list which are greater than 1, and the cost is minimum of this left and the right count. Okay, for this first operation 0 0, for the second operation one element which is less than 5, so left cost is 1, okay, and there is no element which is greater than 5 in the list, that's why the right cost is 0 and mean cost is 0, okay. And the last step, while inserting 2, if you see this is actually already a 156 is already sorted, so we have to insert this 2 in its proper position, and once after the insertion we see that one element is less than 2 and there are two elements which are greater than 2, right? So that's why minimum of 1, 2 is 1. If we closely see this operation, what we are doing? So we are inserting an element to a sorted list, okay, which means we can use binary search here, right? And also while calculating the total cost, the number might be very large, that's why we have to return it modulo 10 to the power 9 plus 7, okay. Now the constraint also says that the numbers are in between 1 to 10 to the power 5, okay. So we will use all these things and we will solve this problem. Let's look at this example 3. This is a little bit interesting because numbers are repeated here, right? So let's look at this line. Cost is minimum of 5 and 0. 5, how 5? Because it is counting all the numbers which are less than 4, even though 3 is repeated 3 times, okay. So this is another thing that we have to consider, okay. Let's look at this example where we are inserting 2 to this list, 1 2 3 3 3 4. If you see this 2, it is getting inserted here, okay. So the left side, the left cost is 1, okay. How many numbers which are less than 2 is 1, that's why mean of 1. And how 4, it is not considering this 2 and it is considering 3 times and 4. So if we see this line, what we can do here, we can find the range, right? We have to exclude all the 2's, right? So we have to find the last index of 2. We have actually done a very similar problem where we find the range of numbers, right, in a sorted array. So I think we have got some idea now how will we solve this. So let's try to write some pseudocode. Okay. So we are going to create a list here. So list of integer, new array list for int num in instructions, right? As I said, we are going to use the binary search and we are going to insert that into a list. Again, I would like to emphasize on the exotic binary search video that I did, okay. You can watch that because that is what we are going to use here, okay. So let's int I equal to EBS, we'll pass the list and the number, okay. This I is nothing but the left cost, right? Right now this list is empty, right? And if I will do EBS on this list for any number, it will give me 0 as my insertion point. There are zero number of elements which are less than me and also zero number of elements which are greater than me, right? So I can say this is left cost for now, okay. I can call the same EBS to find the last index of this number in this sorted list, right? Yeah, let me do that. I can say int last index equal to last index of the number, right? Last index of the number equal to list num plus 1, okay. If we pass num plus 1 to the EBS, we should get the last index of the number. So this is possible if we have already inserted that number into our list. So I can say list dot add my left cost or the insertion point, okay, with the number. Okay. What I did here, I found the insertion point, I inserted that to the list and found the last index of that number by searching the next number. Once I get the last index, the right cost is nothing but the size of the list minus the last index, right? Yeah, so what I can write here, int right cost equal to list dot size minus last index. If that is greater than 0, then I can say list dot size last index, else 0, okay, fine. Now we have left cost as well as the right cost, so we can say int cost equal to math dot min left cost and right cost. So minimum of left cost and right cost will take, and finally we will calculate the total, right? So I can say int total cost equal to 0 and total cost. We'll keep on adding this cost, and to stop the overflow we can say total cost equal to total cost modulo 10 to the power 9 plus 7, okay, fine. So and finally after the for loop we will return total cost, okay, fine. Let's do a little more optimization here, okay. If you see this last index, okay, last index we are doing EBS list and num plus 1. What we can do, we can actually pass the first index, the left cost, right, to the method to search for the last index of that number, yeah, beginning from the left cost, right. So this is one optimization I would do. The second binary search is required only when there are duplicate numbers, otherwise not. First EBS also will update with 0, so starting index will start with 0, okay. We can actually get rid of this second call also. So as I said, EBS is nothing but our exotic binary search. So I have made a video on that. That's a little bit of modification to the plain vanilla binary search, which will return us always the insertion point for an element if it is not present, and if it present it will return the index of that particular number, okay. So I have copied the exotic binary search here. Let's call it EBS, okay. We are dealing with a list which is list of integers. So I'll just modify this EBS a little bit. It will take nums, list of nums, okay. This should be size, okay, and this will take another parameter. I will say start, okay, and I'll get rid of this start, okay. Now this is nums, and this should be nums dot get, because we are using a list here, not an array. So nums dot get, fine, and the target, okay. So this is our EBS method, which will return us the insertion point if it doesn't exist, and if it exists it will return the index of that particular target, okay. This one I will, yeah, left cost, last index, right cost. This should be question mark, okay, run code, okay, accepted, Now we'll take this is the example one. Okay, yeah, this is actually most important. If this will pass, then we know that our code is working fine because we are doing 2 EBS calls. Cool, nice. This is nice. Now let's just submit this. Cool. Okay, this is accepted now. As I told, we can actually get rid of this second EBS call if we know how many times the number is repeated, right? Okay, to know how many times this number is repeated, what we can do, we can actually introduce a cache. We can use a count array, okay, of size, because the numbers are in the range of 1 to 10 to the power 5. So what I can do, 1 4 zeros 1. We can actually get rid of this second EBS call. Right cost is equal to list.size minus left cost first. Okay, and then we will also deduct the number of times this number is present. So that can be done like plus plus count array num. Okay, this is only possible because of this constraint. If this constraint is not there, then feel free to use 2 binary search, and that is still an acceptable solution. Okay, good. Now let's submit this. We can actually further optimize it by using a sorted list, but we are using a list here, which is actually increasing the time complexity here. So the time complexity for this solution is not actually n log n, but n square. So even though this EBS operation is log n, this guy right here is actually eating our time. So if we would have used a sorted list here, then we can say that the time complexity here is n log n. Okay, because this is log n and this will also be a log n operation. Okay, now if we see some examples here from the discussion, they are using binary index tree. In many of this example, they are using binary index tree, but my goal here was to show you a solution which you can come up in an interview environment. Okay, that's it for today, guys, and I think this is definitely a good question for a whiteboard interview. Okay, and if you don't know BIT, remember this is an acceptable solution, so you can write the solution. Okay, and you can always tell that if we use a sorted list, then the time complexity will be n log n, but because we are using a list here, this is increasing the time complexity. I understand it. You can always tell that. Thanks for watching, guys, and this is my channel. I am not going to do thousands of problems in the Leetcode in my channel, but I would like to target certain questions which are very, very helpful to open your thought process for cracking a coding interview. You can encourage me by subscribing or liking my videos. Stay tuned and see you next time. Until then, bye, take care.